Imagine a world where a camera can capture the tiniest details down to 1.7 millimeters from over 100 kilometers away. Sounds like science fiction? Well, China just made it a reality. Using Synthetic Aperture Lidar, SAL, Chinese scientists have developed a surveillance system so powerful it could identify objects, read serial numbers on satellites, and even recognize faces from space. This is 100 times sharper than the best spy cameras we've seen before. But how does it work, and why is this a game changer for surveillance and security? Let's dive in. China's latest innovation in surveillance isn't just an upgrade, it's a revolution. The Synthetic Aperture Lidar (SAL) system pushes the limits of imaging technology, delivering millimeter-level precision from distances once thought impossible. Traditional surveillance relies on lens-based optics, which degrade over long distances, but SAL uses laser pulses to scan an object and measure how long the light takes to return. This allows it to construct ultra-detailed 3D images, even from over 100 kilometers away. The breakthrough happened at Qinghai Lake, one of China's largest inland lakes, where researchers tested SAL against a set of reflective prisms placed 101.8 kilometers away. The results? A stunning 1.7 millimeter resolution, enough to see a grain of rice from nearly a city away. This system is at least 100 times more precise than current military-grade spy cameras and optical telescopes. So, how did China achieve this? A few critical innovations. A 103-watt laser. This is significantly stronger than conventional LiDAR, allowing for clearer imaging over long distances. A 4x4 micro-lens array. Instead of relying on a single lens, researchers split the laser beam across multiple lenses to increase its optical aperture from 17.2 mil to 68.8 mil, significantly enhancing the field of vision. High-frequency laser signals, these operate at over 10 gigahertz, allowing for fine-range resolution that maps surfaces with incredible detail. Real-time data processing and noise reduction algorithms. Unlike earlier LiDAR systems which struggled with atmospheric noise, this new system cleans up distortions as it captures data, delivering sharper and more accurate images. Of course, this breakthrough isn't without limitations. SAL relies on clear atmospheric conditions to function at full capability. Fog, rain, and turbulence in the air could reduce its effectiveness. Additionally, while it can pinpoint static objects with extreme clarity, it cannot yet track moving targets. But even with these challenges, this is an enormous leap forward, setting a new benchmark for extreme-range imaging technology. This is more than just a scientific achievement, it's a strategic weapon. With SAL technology, China now has the capability to monitor foreign military satellites, inspect space assets, and potentially identify human faces from space. This isn't just about spying, it's about dominating the intelligence battlefield like never before. One of the most alarming aspects of this system is its ability to read serial numbers on satellites. This means China could analyze military payloads, inspect adversary spacecraft, and detect damage or modifications with unparalleled detail. In warfare, knowledge is power, and this technology grants China a level of visibility that other nations simply don't have yet. Another critical concern: surveillance of Earth-based assets. If this system were installed on satellites, it could theoretically identify vehicles, military installations, and even track individuals. The implications here are staggering. The ability to monitor troop movements, military exercises, and even sensitive defense projects from orbit could force nations to rethink their security strategies. Historically, the US and its allies have dominated space-based surveillance, but this breakthrough shifts the balance. For context, Lockheed Martin's best LiDAR-based imaging system in 2011 achieved 2 million centimeter resolution from just 1.6 kilometers away. China's SAL system has blown past that not by a small margin, but by several orders of magnitude, achieving a 1.7 millimeter resolution from 101.8 kilometers away. This breakthrough raises serious privacy and ethical concerns. If future iterations of SAL are enhanced to track movement, it could revolutionize facial recognition from orbit, turning satellite imaging into a real-time surveillance tool. Imagine a world where every movement is visible to a satellite with military-grade accuracy. Governments, corporations, and even individuals could be monitored like never before. But while China currently leads in this technology, this is just the beginning. The US, Russia, and Europe will not sit idly by. Expect rapid developments in counter-surveillance technologies, electronic warfare systems designed to disrupt LiDAR signals, and a potential arms race in high-resolution satellite imaging. Beyond military and intelligence applications, this breakthrough has the potential to revolutionize multiple industries, including environmental monitoring, disaster response, and even deep space exploration. One of the most promising uses of cell technology is in Earth observation and environmental monitoring. High-resolution imaging could help track deforestation, pollution levels, and natural disasters in real time. Governments and environmental organizations could use this technology to monitor rising sea levels, melting glaciers, and industrial emissions with a level of detail never seen before. Another exciting application? Disaster response and urban planning. After natural disasters like earthquakes, hurricanes, or wildfires, rescue teams often struggle with gathering real-time, high-resolution images of affected areas. With SAL, satellites could map damaged zones instantly, identifying trapped survivors, collapsed buildings, and blocked escape routes in millimeter-level detail, making rescue operations faster and more effective. But perhaps the most intriguing future application lies in space exploration. Current imaging systems struggle to capture fine details on distant celestial objects, limiting our ability to explore planets, asteroids, and deep space structures. With SAL, scientists could study the surfaces of moons, asteroids, and even exoplanets with unprecedented clarity. Imagine scanning an asteroid from thousands of kilometers away and mapping its surface in extreme detail. This could revolutionize our understanding of space geology and planetary evolution. However, before SAL can be deployed at a global scale, there are major hurdles to overcome. Weather dependency. Since the system relies on laser reflections, atmospheric conditions heavily impact performance. Solutions like adaptive optics and AI-driven corrections will need to be developed. Tracking movement. While current versions of SAL excel at capturing static objects, real-time tracking of moving targets is still a challenge. Future advancements will likely focus on solving this issue. Ethical concerns. Who controls this technology? How should it be regulated? If it falls into the wrong hands, it could enable mass surveillance on an unprecedented scale. With China leading the charge, other countries will inevitably follow, racing to match or surpass this technological milestone. China's development of a synthetic aperture lidar system capable of capturing millimeter-level details from over 100 kilometers away marks a significant milestone in surveillance technology. This innovation not only enhances military and intelligence operations, but also holds promise for a wide range of civilian applications. As this technology continues to evolve, it will be imperative to address the accompanying ethical, privacy, and security considerations. The global community must engage in thoughtful discourse to navigate the implications of such powerful imaging capabilities, ensuring that their deployment aligns with international norms and respects individual rights. If you enjoyed this video, don't forget to like, share, and subscribe for more updates on space exploration and scientific discoveries. And don't forget to leave a comment below. Also, you can visit our website, spaceinews.com. Thank you for watching, and see you next time.